Hi, welcome to the video on evaluating clustering models. By the end of this video, you will be able to explain how to evaluate the results of the clustering model and understand different ways to evaluate clustering results. In the previous video, we compared these two cases. We concluded that case 2 makes more sense and hence the clusters in case 2 are better and more meaningful as compared to the clusters in case 1. Here, we used only two features, that is depth and income. Hence it was easy for us to visualize and decide which of these clusters are better. But in the real world, we will have a greater number of features. Let's take the customer segmentation example. Here we can have features like their income, occupation, gender, age and many more. So, visualizing of all these features together and deciding better and meaningful clusters would not be possible for us, and hence we can make use of the evaluation metrics for evaluating our clusters. The first evaluation metric we will be looking at is called inertia. To understand this, let's take the example of customer segmentation, which we have seen earlier as well. If you recall, the first property of clusters that we discussed was the points within the same cluster should be similar to each other. This is what inertia evaluates. It tells us how far the points within a cluster are. It calculates the sum of distance of all the points within a cluster from the centroid of that cluster. The distance of a point from the centroid within the cluster is known as intra-cluster distance. So, inertia gives us the sum of intra-cluster distances. Now, what do you think should be the value of inertia for a good cluster? Small or large? By looking at this image again, we can say that lesser the inertia value, better our clusters are. Now, let's look at the formula for calculating inertia. Inertia is calculated for each cluster using this formula. So, we take the sum of distances of the points from the centroids of their respective clusters. Here, Wik is a variable which will be equal to 1 if the point xi belongs to cluster k. Otherwise, if the point does not belong to the cluster k, Wik will be 0. Xi is the ith point and mu k is the centroid of the cluster to which the point xi belongs. We iterate it for all the points and clusters and calculate the sum. Finally, we want to minimize this inertia value in order to have better and meaningful clusters. Although inertia considers the distance within a cluster, it overlooks the difference between the different clusters. To counter this issue, let's look at another metric, that is Dunn index, which is used to evaluate the clusters. Dunn index considers the distance between the centroid and points, that is intra-cluster distance, plus it also takes into account the distance between two clusters, that is inter-cluster distance. Dunn index is the ratio of the minimum of inter-cluster distances and maximum of intra-cluster distances. But do we not want to maximize the inter-cluster distance and minimize the intra-cluster distance? Yes, the min stands for the minimum distance between the two clusters among all the inter-cluster distances. Actually here, we are considering the worst case scenario for inter and intra-cluster distance. Now let me ask you, do we want the value of the Dunn index to be higher or lower? We want the worst case of inter-cluster distance to be as high as possible and the numerator should be as high as possible. On the other hand, we want the worst case scenario of the intra-cluster distance to be as less as possible, that is, the numerator should be as low as possible. Hence, the higher the value of Dunn index, the better the clusters are. Now that we have understood the basics of clustering, its application and evaluation metrics, in the next video, we will be focusing on the clustering algorithm called k-means. See you then.